Developing the sum and difference formulas for the sine, cosine, and tangent can be done by knowing one of these identities, and that is the sine of the sum identity. And so starting with, you would see that the sine of alpha plus beta is equal to the sine alpha cosine beta plus cosine alpha sine beta. To go to the subtraction identity, or the difference, all you have to do is understand that it's a plus negative beta. So I'm going to substitute in negative beta for my beta. And if you did that, the cosine negative beta is just equal to a cosine beta because it's an even function. That's why the sign does not change here. And the sine negative beta equals negative sine beta because it's an odd function, and that negative would come out front. So that's how you're able to convert between the two, even and odd functions. Same thing can be done with cosine and tangent. So let's go and see how to develop the cosine sum identity from the sine sum identity. And what I'd like to do is start with the cosine sum, and remember that the cosine of an angle equals the sine of the complement of that angle. And that's the first thing that we're going to apply here, is that these two are equal. And then once you do that, I'm going to rearrange these terms and write 90 minus alpha minus beta. Now the reason why I do that is because I know that the sine of 90 minus alpha is equal to the cosine alpha. Those are co-functions. Again, using those identities that we've seen before. And so I use the sum of the difference of the signs in here to look at, to expand that. And once you do expand that, you would see that the sine of 90 minus alpha equals cosine alpha, and the cosine of 90 minus alpha equals sine alpha. And therefore, you would see that this is equal to the sum of the cosines. Again, you could do the difference of cosines by substituting in a minus beta, and we put that in again. This becomes positive, this becomes negative, and you would see the sign change on the other one. Now the tangent is formed by simply putting the sum of the sine over the sum of the cosine. And when you substitute in, you get this expression. Now this expression looks very confusing, but if you know that you want to get a 1 right in this position right here, then what I really want to do is divide the top and the bottom by that term. And that's what you're doing in the very next step. I want to divide the top by the cosine alpha cosine beta. And I want to divide the bottom by cosine alpha cosine beta. And remember that you have to distribute that all the way through on the top and on the bottom. And if you do so, you would get to the second step. Now you have a lot of cancellations, such as this first one. Cosine alpha remains, cosine beta cancels, so you're left with sine alpha over cosine alpha, which is just tangent alpha. Secondly, if you're to look at it, the cosine alphas cancel. You're left with sine beta over cosine beta, and that's a mistake right there. That should be a beta. That becomes tangent beta. These two cancel, leaving you with 1, and then you're left with the last one, which simplifies down to this. So that's basically how you prove the sum and difference identities for cosine, sine, and tangent, given the sine of alpha plus beta. The reason why we're given this is because that's a lot more complicated proof, but if we're starting with this, we can quite easily develop the formulas for the other ones.